We started with a composite skeleton based on Laforaci 1 and other finds, and over nearly 3 months we've carefully been reconstructing him. With extraordinary attention to detail, the muscles were painstakingly added to rebuild his body. His face was recreated using forensic techniques. Then the skin and hair were added. Now he's finished and he's here. So should we go and have a look?
I can't wait.
Yeah.
This is so exciting. We have literally never seen this before. Under a sheet. Go on then, Victor. Wow. Oh my goodness.
Wow, his hair's sparkling.
He's really lifelike.
Yeah.
The nose is really prominent,
That is
isn't
just
it?
fantastic.
Still trying to get my head around the fact that this guy is in my ancestry and not that far back. John, what do you think?
Give me a break. You look like twins.
Isn't he wonderful? I mean, this just looks like a living, breathing Neanderthal. I'm slightly freaked out by him, actually. I just think he's going to start moving.
That is unbelievable. It's uncanny. It's
John, what
spooky.
do you reckon?
You know, it's just got this sort of humanizing effect to put the flesh on, and it's the challenge is to make something that's different from us look different, when in fact the details point to great similarity.
Oh, I can just imagine him striding off. What do you reckon? Is he muscly enough?
Yeah, he's got to be, but it's really impressive, isn't it?
It's a case where focusing on bone doesn't give the whole picture.
Yeah. Victor, such a good job. He's absolutely brilliant.
Replica of a skull from Nigeria, and it was dug up in 1965 by Thurston Shaw and his team, an archaeologist. It is about 13,000 years old, and my colleague Katerina Havarti used a new technique of digitizing the surface of the skull in 1972, and she found, as I did, that it does not look like recent African material. So here we've got a recent African skull, and here's the skull from Iwo Eleru in Nigeria. You can see that this skull is much longer, it's much lower, and all in all it's got a much more what we could call primitive appearance, even though it's only 13,000 years old. And in Katerina's analyses, she found that the nearest neighbour in terms of the overall shape of the skull was this specimen from Tanzania, from a site called Ngaloba, which is, we think, about 140,000 years old. So you've got a specimen that's only 13,000 years old, but it looks like it should be, you know, another 100,000 years older in terms of its shape.
So what's going on?
So this suggests that human evolution in Africa was more complex, that the transition to modern humans was not a straight kind of transition and then a cut-off. The archaic humans did not necessarily die away once they'd given rise to modern humans. They may have been living in some parts of Africa alongside, in a sense, their descendants, and perhaps exchanging genes with them. Just as Neanderthals seem to have interbred with people outside of Africa, archaic humans in Africa could have been interbreeding with modern humans inside of Africa, and this skull may show a reflection of that interbreeding between archaic and modern humans.
Well, so just to update where we stand today, now we have to add another admixture process in Africa, along with the two outside of Africa. And I just wanted to end by saying something about what kinds of models are supported by the genetic evidence. Certainly we can no longer believe that the right replacement model is correct. Even after 25 years of dominating as a paradigm, it seems to have fallen. And the new models that seem to be relevant are models that were also proposed many years ago based on fossil data. I think that this is probably the most reasonable model. It's a replacement model with hybridization, but I'll skip over that, as there doesn't seem to be a single location for transition in Africa. There's no single Garden of Eden. There's transitional forms that are spread very vastly across the continent. Therefore, there's certainly the opportunity for gene flow among these morphologically diverged groups over a long period of time. And I really like the idea, Chris already described it, where you have the multi-regional model now restricted to Africa.
Advances in genealogical DNA testing have raised existential questions for many, but not much compares to the experience of Albert Perry, whose genetic material offers new clues about the origin of the human species. An African-American man from South Carolina, Perry let a relative send in his DNA for analysis, but when the testing company tried to track his Y chromosome, they simply couldn't. Further research revealed that Perry's Y chromosome came from a lineage that broke off from other species about 338,000 years ago. That's long before the first Homo sapiens, or modern humans, evolved some 195,000 years ago, making our Y chromosome lineage much longer than geneticists believed. Researchers eventually linked Perry's DNA to other men in a village in Cameroon, leading them to speculate that modern humans and a since extinct species interbred in Central Africa hundreds of thousands of years ago.
1.8 million year old skull has the A 1.8 million year old skull has the science world all excited. That's because it might rewrite an early chapter in human evolution. Scientists have spent 8 years studying this fossil. It's the only complete skull from a hominin species from that time period, making it a big find for researchers. But the skull, nicknamed Skull 5, wasn't found alone. There were at least 4 other skulls at the site in Dmanisi, Georgia, and the individuals are thought to have died within a few hundred years of one another. When the researchers compared the specimens, they found a lot of variation in the shapes of the skulls, variation that might have led scientists to believe they found separate species if the fossils hadn't all been found in one place. The lead researcher says since we see a similar pattern and range of variation in the African fossil record, it is sensible to assume that there was a single Homo species at that time in Africa. Catch that? He's saying that when scientists found skulls from what they thought were different species, like Homo ergaster, Homo rudolfensis, and Homo habilis, they were actually looking at members of one species, Homo erectus.